Welcome to the DIY Honda Garage channel. The Honda Civic models from 2006 to 2011 can experience various diagnostic trouble codes, including DTC P0112, which specifically indicates a low voltage issue in the intake air temperature IAT sensor circuit. The IAT sensor is crucial for optimal engine performance as it measures the temperature of the air entering the engine. This information helps the engine control unit, ECU, adjust fuel delivery and ignition timing to improve fuel efficiency and reduce emissions. The IAT sensor is typically located near the air intake manifold or integrated into the mass airflow (MAF) sensor assembly. Before proceeding with any troubleshooting, it is essential to record all freeze data, which provides a snapshot of data when the fault occurred, and any onboard diagnostic snapshots to provide insight into the vehicle's state during the failure. Understanding these elements is integral to effectively diagnosing and repairing the issue. The intake air temperature IAT sensor plays a pivotal role in measuring the temperature of the incoming air, enabling the engine control unit, ECU, to make necessary adjustments for optimal combustion. Typically, this sensor is located in the air intake duct or within the mass airflow (MAF) sensor assembly, allowing it to closely monitor air conditions. An IAT sensor that reports low voltage signifies that it's either malfunctioning or that there's an issue in the circuit itself. Low voltage readings could lead to inadequate air-fuel mixture adjustments, causing poor engine performance, increased emissions, and reduced fuel efficiency. It's crucial for the IAT sensor to function properly during various driving conditions to maintain engine efficiency and reduce wear on components. The proper functioning of the IAT sensor ensures that the vehicle operates within its designed parameters, preventing unnecessary strain on the engine system. Several factors can contribute to the triggering of DTC P0112. A primary concern is a faulty IAT sensor itself, which may fail due to age, exposure to heat, or chemical contaminants. Additionally, wiring issues such as frayed, shorted, or disconnected wires between the IAT sensor and the engine control module, ECM, can lead to erroneous voltage readings. Connections at the MAF sensor, IAT sensor, or ECM can also suffer from corrosion or looseness, contributing to intermittent connectivity issues. It's worth noting that a malfunction within the ECM, which interprets sensor signals and controls engine functions, could incorrectly indicate low voltage in the circuit. Properly diagnosing the issue requires careful examination of the sensor and its connections before considering the ECM as a faulty component. Understanding these potential causes aids in more efficient troubleshooting and repair. The symptoms associated with DTC P0112 include a noticeable reduction in engine performance. This can manifest as sluggish acceleration or hesitations during powered operation, impacting the overall driving experience. Drivers may also notice a drop in fuel efficiency, as an improper air-fuel mixture can lead to excess fuel consumption and diminished mileage. Furthermore, the vehicle's check engine light will likely illuminate, signaling the presence of a malfunction that requires attention. These symptoms often occur in tandem, as the vehicle's engine control system struggles to compensate for the inaccurate air temperature readings from the IAT sensor. It's critical to address these symptoms promptly to prevent further damage or complications within the engine system, ensuring that efficient and smooth operation is restored. In the first troubleshooting step for DTC P0112, you need to turn the ignition switch to the on to position, ensuring that electrical systems are activated without starting the engine. Once in this position, Use the Honda Diagnostic System, HDS, to check the readings from the IAT sensor in the data list. As per the guidelines, if the IAT sensor indicates a reading of 356 degrees Fahrenheit, 180 degrees Celsius or higher, or a voltage reading of 0.08 volts or less, it confirms a potential fault. In this case, the next step involves deeper investigation into the system. Conversely, if the readings show normal voltage, this may suggest an intermittent failure. In that scenario, the focus should then shift to examining connection quality at the MAF and IAT sensors and the engine control module, ECM. This bifurcation in the troubleshooting process is essential for narrowing down the source of the problem effectively. In this second step, you begin by turning the ignition switch to lock, 0, to safely prepare for component disconnection. After securing the vehicle in this state, disconnect the 5P connector of the MAF sensor/IAT sensor. This action serves to isolate the sensor from the system for a clearer diagnostic examination. Once disconnected, switch the ignition back to the on position and again utilize the HDS to check the IAT sensor readings. As before, if the readings show 356 degrees Fahrenheit, 180 degrees Celsius or higher, or a voltage of 0.08 volts or less, it indicates a persistent problem in the circuit. However, if the readings fall within the normal range, moving directly to step 11 is advised. This step allows for an effective assessment of whether the IAT sensor itself is faulty, or if an issue lies elsewhere within the electrical circuit. In the third troubleshooting step, begin by turning the ignition switch back to lock, 0, to ensure safety while you work on the electrical components. With the ignition off, utilize the HDS to jump the SCS line, which stands for Service Check Signal. This step allows for fault code manipulation and reporting clarity. Next, proceed to disconnect connector B, 44P, from the ECM, or Powertrain Control Module, PCM, which functions as the brain of the vehicle's engine management system. At this point, you're isolating the engine control unit from the diagnostics to further investigate potential circuit issues. This step is critical as it enables you to differentiate whether the problem resides in the sensor circuit or is an isolated incident involving the ECM-PCM itself. In this fourth step, you'll need to check for continuity between terminal number 2 in the MAF sensor IAT sensor 5P connector and the vehicle's body ground. This step is critical to rule out any interruptions in the electrical circuit that could be affecting sensor readings. You will utilize a multimeter to measure continuity in this specific wiring path. A successful continuity check indicates that the wiring is intact and functioning as intended. However, if no continuity is detected, this points to a potential short circuit or break in the wiring between the sensor and the ECM/PCM. Identifying and repairing any short or fault in the wiring at this stage is essential for restoring proper circuit functionality, as failure to do so will lead to recurring DTC P0112 indications. In the fifth troubleshooting step, if continuity checks reveal an issue in the wiring, or if other indications point to a malfunctioning IAT sensor, you'll want to begin by turning the ignition switch to lock 0 to ensure safety. Following this, replace the IAT sensor with a new component as a preventative measure. Given that IAT sensors can become inaccurate over time due to mechanical or environmental stress, replacing it can often resolve the issue. Once replaced, proceed to reconnect all connectors that were previously disconnected to ensure proper integration back into the vehicle system. Particularly with electronic sensors, it's important to maintain clean and secure connections to prevent future faults from developing. Completing this step effectively prepares the system for the next phase of troubleshooting. In the sixth step, after replacing the IAT sensor, it is vital to reconnect all connectors that were previously disconnected. Ensure that each connection is secure and free from corrosion to maintain integrity in electrical communication. Once all connectors are properly seated, turn the ignition switch to the on/to position. Following this, use the Honda Diagnostic System, HDS, to reset the Engine Control Module, ECM, or Powertrain Control Module, PCM. Resetting the ECM/PCM clears any fault codes and allows the system to relearn sensor adjustments and parameters. This step is crucial, as it prepares the vehicle's engine management system for further testing and evaluation to ensure normal operation has resumed. After this reset, the vehicle should be ready for the next step in ensuring proper function. In the final troubleshooting step, you need to perform the ECM/PCM idle learn procedure. This process ensures that the newly installed IAT sensor is properly integrated into the engine management system, allowing the vehicle to adjust the idle speed as required for optimal engine performance. Once the idle learn is completed, reconnect the HDS to check for any pending or confirmed DTCs. This is particularly crucial to confirm whether DTC P0112 reappears or if the system is functioning correctly. If DTC P0112 does reappear, it indicates that further investigation into connections or other sensor issues is necessary. However, if no DTCs are indicated, it confirms that the troubleshooting has been effectively completed and the vehicle is operating within its expected parameters. Final verification of repairs after addressing DTC P0112 is essential to confirm that all faults are resolved. This involves conducting a road test to evaluate the vehicle's performance under various conditions, ensuring that there's no recurrence of engine performance issues. During the road test, pay careful attention to the responsiveness during acceleration and overall engine behavior, particularly the idle. Monitor the vehicle's computer systems using the HDS to check for any re-triggered DTCs. By evaluating both operational performance and system functionality, this verification step ensures a comprehensive confirmation that the repairs made were indeed successful. It's critically important to confirm that the vehicle is now operating at optimal levels, effectively addressing the initial concerns. Preventive maintenance is key in ensuring that issues like DTC P0112 do not arise in the future. Recommended practices include regular checks of the IAT sensor and its connections, ensuring that everything remains secure and free of corrosion or wear. Additionally, validating sensor operation during regular service intervals helps catch discrepancies early on. Following the manufacturer's recommended maintenance schedule provides further guidance on when to change components, perform fluid changes, and monitor associated systems. These proactive measures can prevent unexpected breakdowns and ensure that the engine continues running smoothly and efficiently. Taking care of these aspects helps maintain optimal performance while extending the vehicle's lifespan. In conclusion, DTC P0112 represents a critical issue concerning the intake air temperature sensor and highlights the importance of diagnosing low-voltage conditions accurately. Understanding the IAT sensor's role in engine performance is essential for any technician, as it significantly influences fuel mixture accuracy and emissions. Through a systematic approach to troubleshooting, as outlined, technicians can efficiently identify the root causes of the problem. Whether it's a faulty sensor or problematic wiring, each step contributes to a resolution that restores vehicle function. Ultimately, keeping an eye on preventive maintenance can significantly reduce the likelihood of experiencing similar codes in the future, safeguarding both the vehicle's performance and the driver's experience. Please like and subscribe to the channel. See you next time.